Next talk is from SCIEX. I believe, Blair, you're controlling the slides and you should have control of my mouse.
Great, thank you very much. Good morning, everyone. A collaboration between SCIEX, Bayer, and Boehringer Ingelheim, we have created a conversion utility, an ADF-enabled add-on to the analyst software to produce a pipeline enabling us to apologies, I'm having a bit of trouble with my audio. Enabling us to solve two particular use case problems that are pretty much universal to all organizations. The first is interfacing to LIMS. In the past, the SCIEX software has required some fairly elaborate middleware in order to transfer data into a LIMS. And then the second use case is for archival. To review briefly from our previous presentations, we implemented a converter in two pieces. On the analyst software side, we extract data, place it in a data model that is hierarchical and exposes all of the information for a run. And the other piece is a cloud-enabled converter where the analyst data model is converted to an ADF file. I'll turn some time over to Henning from Bayer to talk about their particular implementation and the larger picture there at Bayer.
Yeah, thanks very much, Blair. So my name is Henning Kaiser from Bayer, and I'm actually like to share you a bit where we're actually coming from. So we realized over the last years, or probably everyone does who did digitalization of labs over, again, maybe you can turn back one slide, if possible, to the previous one. You realize that you start connecting more and more systems and ending up in bilateral interfaces between different kinds of systems, between ELNs, between LIMS system, between instrument control system, and all these, or many of these applications actually lock the data down. So you have to, the access to data is not really separated from the apps, and this ends up only in my function where I'm working at, that we are dealing with more than 100 different scientific applications. Not all of them needs to be interlinked, but you see the picture that changes are very costly. The interfaces are not really maintainable, and so we decided for a way forward how we can like escape this interfacing gridlock, and decided to go with a more data-centric and a system architecture, following also a data strategy. So the work that we are doing now with SCIEX and Boehringer is, as you see on the right side, serving us in the target state that we can have a standard defined transfer package that actually contains the metadata, the context data, and the processed and raw data in a fair way. I was thinking similar to drive an analogy, what Dennis pointed out earlier today, not finding a wrecked airplane, but if you think of the NASA mission Voyager, which is a space ship traveling, I think, for 3-4 decades right now, which has a golden record, for instance, on board with the most significant music on this plane that any alien or extraterrestrial life could actually see what humans are about. We think about our lab data should be encapsulated in a similar way, that if anybody finds it, he should himself be able to get the context on it and also be able to process it and have a look at that, independent from like the the system of record that actually was used to create it. And we chose to use the allotrope data format in particular for the instrument data to serve us on this purpose. So from the round trip, helping us to bring data into an archive, but also, as we showed earlier this year already, we have already a productive LIMS interface also with, from SCIEX Analyst in place, which serves us the need to transfer the data from one system to the other, also that we are able to separate data from applications. And yeah, with that, I'd like to hand it back to Blair to show us what, in particular, what are the newest developments and where we are at.
Thanks, Henning. So this phase of our project was to create a viewer for the ADF files that have been created by our analyst interface. Of course, it's very difficult to review data without a full-featured viewer. This viewer is a standalone application, meaning that it can be run independent of the analyst software, which is in contrast with the implementation of the converter, where in order to convert or at least extract the data from the analyst environment, it requires that the analyst software be installed on the machine. For the sake of convenience, we have included our conversion interface locally in the viewer application. So there will be two ways to produce an ADF file. One is via the WebSocket interface, the architecture, and the other here locally. The data included in the ADF file includes raw spectra, method information, the quantitative data, audit trails, and the native files generated by the analyst software. We have implemented a SCIEX-specific model. It is essentially a hierarchical data model where at the top we have a result set. Beneath that we have the multiple samples in a run, and associated with each sample we have the analyte information along with the measured values and the metadata for that analyte. So the viewer has some features and functions. It reads that data file. As it's reading that data file, it verifies that the version of the file is suitable for the version of the viewer. It also determines that the ADF file actually contains a result table graph, as we'd expect. It displays data in both tabular and hierarchical format. The tabular data has been flattened to correspond with the way that the analyst software displays data. We also have a hierarchical view, essentially a tree view, where one can drill into the hierarchy and look at any information there. We have the ability to display and review the total ion chromatogram and the extracted ion chromatograms for any sample or analyte combination. Two features that we've added for both convenience and to enhance the human readability is an export to TTL format and XML format. The viewer uses at this time a SCIEX-specific vocabulary. We will be harmonizing that vocabulary with the allotrope vocabulary. However, to facilitate that, we've added a feature to the viewer that allows us to manipulate that vocabulary, and we'll see that in the demo. We're able to update the URIs for vocabulary terms as well as for units there. So ready for a demo, Jamie? I'm hoping you can see my desktop with a...
Yeah, we do.
With an analyst result table.
Yep,
so this
we can
is a
see it.
result table produced in Analyst. It contains 49 samples. For each sample, there are 2 analytes with their associated internal standards. This tabular view is flattened, and so we're seeing some information duplicated. For instance, the sample name is the same for all of the analytes for the sample. So one row here is a single analyte in a single sample. There's quite a lot of data here, and this view doesn't even include all of it. Some of it's not available through the UI. So when we have completed our processing of the run and we are content with the condition of our result table, we can launch the viewer and create an ADF file. Now the viewer will read the results table that's currently displayed in Analyst and create an ADF file from that. So we have a status bar down here telling us what it's doing right now. One point to consider here is that this ADF file will contain about 200 data cubes holding the spectral data. And it's actually quite performant, at least for the raw data files that Analyst produces. Having created the ADF file, we can view it in the viewer. Now, it's not necessary to create an ADF file, a fresh ADF file in order to view it. I can open any ADF file that I've previously created. So here we'll read the ADF file and reconstitute the data model that's contained in the ADF file. So here we have a similar tabular view containing all of the tabular data that's available for that particular result table. Peak widths, peak heights, baseline slope, concentration, calculated concentration, accuracy, and so on. In this tabular view, we are able to view the total ion chromatogram for any of our samples. And as we scroll through the list, it updates that tick view. We can also view the extracted ion chromatograms. So here in blue, we have the internal standard and the analyte in green. And again, we can scroll through that and see what we like. The hierarchical view is presented as a tree and contains all of the information that we could see in the tabular view, and some additional information such as the actual quantitation method. We can view the audit trail. We can see what native files have been attached, and so on. So this is a better representation of the actual data structure than the tabular view. If we need to modify the vocabulary, here we have a table with the analyst properties mapped to a URI and, where appropriate, a unit. We also have a scope note for each of those so we can understand what we're looking at. If we wish to, we can export the data as a TTL. And we'll just jump out and take a look at that. So here's the TTL for that results table, and that's using the built-in ADF GINA export routine. We can also produce an XML file of the same data. Where we see the unit URIs, we have each data item, and this is being reconstituted from the ADF file that we created earlier. So this is our viewer. Can we go back to the slides, please? So we have some additional work planned. We will integrate this viewer with ADF Explorer so that we can see the graph view and the raw triples in the ADF file, as well as all of this in the same place. When it's possible to do so, we will harmonize with the MS data shape. Even prior to that, we will harmonize the vocabulary with the ADF, well, with the allotrope vocabularies. We'll produce some documentation. We will create those artifacts necessary to validate the software for GLP use. And we will, at some point, support the SCIEX multi-quant processing software, as well as our next generation instrument control and processing software, SCIEX OS. Are there any questions?
Thanks, Blair. So it looks like we have about 15 minutes before the next talk if we want to take some more questions live. There was one in the chat window, which I think I'll open it up to the product team while we're waiting if anyone else has any questions. Are all vendors that are members of the Allotrope Consortium engaging in a coordinated and aligned partnership to develop an ADF file standard for mass spectrometry data? Otherwise, what are we gaining?
I think that's a great question, Jamie. So, hi everyone, this is Corey Baklarski, Vice Chair of Allotrope. You know, this is really timely because we've just rebooted the MS working group, right? So the working group has been going for a couple years, and you know, just recently we've started to refocus and reinvigorate that group to really focus on some of the things. I think a lot of the things here that Blair was showing and that Henning was talking about. So maybe the question is, you know, it'd be great, I think, to engage in a dialogue with the work that's been going on here and with the team at SCIEX to see how can we use what's been done here, right? You know, you spoke to being able to integrate the vocabularies and to integrate the data models. You know, how can we use what you've shown this morning, which is very impressive, to be able to sort of jumpstart that and make sure that, you know, we're all working together. I don't know, Blair, Henning, if you had any thoughts on that.
This is Blair. So we have known all along that ultimately that was the goal, that there would be an allotrope standard for LC-MS data. We have been anticipating output from the MassSpec data shape working group in order to facilitate that. As part of our efforts, we've been very careful to design our software so that it is convenient, or at least relatively convenient, to make that transition to a unified data shape. And that's an important goal for us. That's a goal also for our plans for incorporating other software that we produce, including SCIEX OS. I mentioned multi-quant. We do have other software that will come under that umbrella. So we're very conscious of that. We have plans to implement that, and we are participating in the MassSpec data shape working group. In my discussions with Paul from BI and Henning, we have recognized the need for that, but we've also realized that there's value to get from this even prior to that. So that's the route we're taking.
Thanks, Blair. Yeah, I think it'll be really great, if, I'd extend an open invitation for you to come and, bring the bits and pieces here of the model that you've created, to the working group, so that way we can make sure that we can incorporate it.
Could we unmute Dave Abramowitz? He has some comments that he'd like to add to that.
There we go. Thanks, Blair. Thanks for, yeah, Corey, we'll be happy to, as I said earlier to you, SCIEX would be more than happy to be as much involved and to bring what we've done here to the working group and help it use it as a basis for the MassSpec data model. I mean, that makes sense. We've started it. Why not leverage what we've done and then add to it? I agree.
Great. That's great to hear. So I'm sure we'll follow up in the coming weeks on that.
Absolutely. Thanks, Corey. No problem.
And then Steve from USB had his hand up. Oh, he took it down.
I'm sorry, I'm off mute now. Thanks, Jamie. Yeah, Blair, great presentation. And, I was looking at our monographs that use MassSpec, so would love to connect with you on maybe piloting some content within there and within this MassSpec working group from the compendial methods perspective.
Sure thing, love to.
It looks like there was one more question in the chat from the attendees. And the question is the intent for the SCIEX ADF viewer to be accessible to non-SCIEX customers?
Dave, do you want to take that?
We are still evaluating all distribution and commercial opportunities for what we will develop. So of course, that's my plan, but I can't say exactly when that will happen, but that is the plan, yeah.
Great. Jamie, do you know, are there any other questions for the presentation here?
No, it doesn't look like it.
So can I make one more comment on that last question?
Certainly.
So I think we would be happy to collaborate with other vendors to bring their model into what we've done here. And when that's harmonized, I think we will have opportunities to make this converter and viewer technology available generally. I think a very important prerequisite for that is that we do have the standardized model. Once we have that, it's semi-trivial to take a vendor-specific MassSpec data model and add it here. This whole application end-to-end is very modular, and we've anticipated having standards on both ends that can be utilized. Thanks.
Great, thank you, Blair, and thank you, Henning.